Okay, so once again, good morning. So our discussion once again is the software architecture, and maybe some part of the software design patterns must be also covered. No, so again, the software architecture patterns are a structural layout that are used to solve commonly faced design problems within the software development industry. And these patterns are used to prevent startups from having to reinvent the wheel every time they start a new project. And this pattern should not be used to design the entire project, but rather different patterns should be used to create individual components of the overall design. And due to the rising complexity of today's current software, the associated development, maintenance, and enhancement tasks have become increasingly tedious and time-consuming. So as a result, software architecture patterns have been created not to ease the workload for software architects, developers, and operators. So, and these patterns actually are a reusable solution to a commonly occurring problem within the field of software design. Again, software architecture patterns are a description or template for the structural organization or a scheme for how to solve problem that can be used in many different situations. And you think of them as formalized best practices that your startup can use to solve common problems when you are designing your software product. Okay, to give us more details about the topic, let us all welcome our presenter.
So, good morning, sir. Good morning, classmate. My topic is all about system architecture. So, what is a system architecture? Translate the logical design of an information system into a physical structure that includes hardware, software, network support, and processing methods. An effective system combines elements into an architecture or design that is flexible, cost-effective, technically sound, and able to support the information needs of the business. So system architecture uh, is a formal description and the presentation of a system and organized in a way that supports reasoning about the structures and behavior of the system. So system architecture checklist, enterprises resource planning or ERP. The objective of ERP is to establish a company-wide strategy for using IT resources. So ERP is a type of software that organization used to manage day-to-day business activity po, such as accounting, procurement, risk management, and compliance. And of course, and also the supply chain or supply chain management. So initial cost and TCO. So it is the purchase of an asset plus the consist of operation. So during the final design stage, you may you make decision that will have a major impact on the initial cost and the total cost of ownership for the new system, and it should be review all previous cost estimate. So scalability, it is also called extensibility. So it refers to a system ability to expand, change, or downsize easily to meet the changing need of a business enterprise. So it is especially important in implementing systems that are volume rated, such as transaction processing system. So web integration. Uh, an information system includes applications. It is a web-centric architecture and avoids many of the connectivity and compatibility problems. Example of this is e-marketplaces. So web integration is when your website sends or receive information from another website or application. It means that rather than your website being an isolated system that doesn't talk to anything else, it can make friends connecting with other key system to save time and give other benefits. So legacy system interface requirement. So the new system might have to interface with one or more legacy system. Interfacing a new system with a legacy system that involves analysis of data, formats, and compatibility. The analyst must know if the new application eventually will replace the legacy system. So processing option. So in planning the architecture, designer also must consider how the system will process data online or in batches. Provision must be made for backup and speed recovery in the event of the system failure. So security issues, security threats and defense are a major concern to a system analyst. The analyst must consider security issues that relate to system design specifications. Web-based system introduce additional security concern. So in planned architecture, we have servers. Uh, Server is a system that provides resources, data, service, or program known as a client. So a client is a system that use remote services from a server. So maintain architecture is the design of mainframe computers used for large-scale computing applications such as data storage or customer statistics, as well as processing other types of um, bulk information. So, and we have a server-based processing is a computer responsible for the storage and management of data files so that other computers on the same network can access the file. So, client, as a PC technology exploded in the mid 1980s and 1990s, powerful microcomputer quickly appeared on corporate desktop. Uh, User found that they could run their own word processing, spreadsheet, and database application. Companies like link the standalone computer into network. So clients standalone computing, uh, it is a local and wide area network, and it is a client-based processing. So file server design. A file server is a server where statistic files are being saved, stored, and accessed inside a network. So a client server design is also known as a networking computing model or server network because all the requirements and services are delivered over a network. So this is the characteristic of client server. Now, and we have a path client. So it refers to a client computer that is powerful and fully features in its own right, apart from the server and network. And we have also a team client. It's a system that runs from resources stored on a central server instead of a localized hardware. So we have a network traffic. So in the path client, it is higher because the path client must communicate more often with the server to access data and update processing results. In a thin client, it is lower because most interaction between code and data takes place at the server. So in performance, it's slower because powerful hardware is required. In a thin client, faster because less network traffic is required. So in the initial cost, it is a higher in a path client because more powerful hardware is required. So a thin client is a lower because workstation hardware requirements are not as stringent. So In a maintenance cost, in a flat client, higher because more program code resides on the client. So in the thin client, lower because most program codes resides on the central server. So ease of development. In the flat client, it is easier because system resemble traditional file server design where all processing was performed at the client. So in the thin client, most difficult because developers must optimize the division of processing logic. So we have a client server tiers. So two-tier design is a software architecture in which a presentation layer or interface run on a client and a data layer or data structures get stored on a server. So while the three-tier design is a client-server software architecture pattern in which the user interface, functional process logic, and data storage and data access are developed and maintained as independent module. So middleware, it enables the tiers to communicate and pass the data back and forth. It is to provide a transparent interface. So it can integrate legacy system and web-based application. So middleware is a software which lies between on operating system and the application running on it. So cost benefit issue. A client server system enable to firm to scale the system in a rapidly changing environment. So client server computing also allows companies to transfer applications from expensive mainframes to less expensive clients platforms. So client server system reduce network load and improve response time. So client server performance issues. Uh, in contrast to the centralized system, a client server design separates application and the data. So distributed database management system or DDBMS. So the system is scalable. So new data sites can be added without reworking the system design. So the system is less likely to experience catastrophic failure. So we have a package solution and e-commerce service providers. Many vendors offer a turnkey system for their own companies. Uh, and another alternative is to use an application service provider or ASP. And it provides application and related service uh, over the internet. So another option is managed hosting, and it considers the experience for up other companies in the same industry. So corporate portals, a corporate portal can provide access for customer, employees, supplier, and the public. Cloud computing, it is effectively eliminates compatibility issues and scaling on demand, and it requires significantly more bandwidth. So Web 2.0 envision a second generation of the web that will enable people to collaborate, internet, and share information more dynamically. So example of this is the Wikipedia and social media site. And Web 2.0 refers to websites that emphasize user-generated content and is of use, participatory culture, and interoperability for end user. So online processing, it is the ongoing entry of transaction into a computer system, and it is a real time. So because it is interactive, online processing avoids delays and allows a constant dialogue between the user and the system. Online processing also can be used with the file-oriented system. So batch processing, it is the processing of transaction in a group or a batch. So the IT operations group can run batch programs on a predetermined schedule without user involvement and during regular business hours at night or on weekend. It requires significantly fewer network resources than online system. So network models. Uh, the OSI or Open System uh, Interconnection Reference Model. Uh, it describe the 7 layers that computer system used to communicate over a network. So each layers perform a specific function and it offers set of design and standards. So we have a physical layer. It is the lowest layer of the OSI. Uh, it is concerned with electrically or optically transmitting raw structured data bits in across the network from physical layer of the sending device to the uh, physical layer of the receiving device. So it transmits raw bit stream over the physical medium. So next is the data link layer. The data link layer directly connected nodes are used to perform nodes to node data transfer where the data is packaged into a frame. So next is the network layer. It is responsible for receiving frames from data link layer and delivering them to their intended destinations. Uh, among based on the addresses contained inside the frame. So we have next is we have a transport layer. It's manage the delivery and error checking of a data packets. It also transmit data using transmission protocols, including TCP and UDP. So next is the session layer. It controls the conversation between a different computer and maintains connections and is responsible for controlling ports and session. So next is a presentation layer. It's ensure that the data is in a usable format and is where the data encryption occurs. And lastly is the application layer. So at this layer, both the end user and the application layer interact directly with the software application. So network protocols. Uh, network protocols is an established set of rules that determine how data is transmitted between the different devices in the same network. So in all cases, the network must use a protocol. It's transmission control protocol, internet protocol. So TCP, IP. So TCP provides communication between an application program and the internet protocol. So we have a FTP, file transfer protocol. It is a set of protocols that the network computers use to talk over the internet. Using an FTP client, we can upload, download delete, move, or rename and copy the file on a server. So, network topology. It is a hierarchical network. It mirrors the actual operation flow in the organization. So, and interconnects multiple groups that are located on the separate uh, layers to form a larger network. So, one disadvantages of a hierarchical network is that if a business adds additional processing levels, the network becomes more complex and expensive to operate and maintain. So, bus network. It is a topology for a local area network or LAN, in which all the nodes are connected to a single cable. So the devices can be attached or detached from the network at any point without distributing the rest of the network. It is the overall performance declines as more users and devices are added. So today, the bus design is much less popular. So ring network, it is a network topology which each nodes connects to exactly two other nodes. So it's forming a single continuous pathway for signal through each node and a ring. So one disadvantage of a ring network that if a network device fails, such as a PC or a server, the devices downstream from the failed and device cannot communicate with the network. So star network, uh, it, it is a local area network topology in which all nodes, personal computers, workstation, or other device. The disadvantage of the star design is that the entire network is dependent on the switch. However, in most large star network, backup switches are available immediately in case of hardware failure. So, mesh network, uh, there is no central connection point. Instead, each is connected to and at least one other nodes are and usually two move than one. So while this design is extremely reliable, it also is very expensive to install and maintain. So it's originally developed for military applications. So routers uh, is a device that provides Wi-Fi and it's typically connected to a modem. So routers differ from switches in that they work at a higher OSI level and can connect to a larger dissimilar network such as the internet. And gateway is a node or a router in a computer network. It's a key stopping point for data on its way or from other networks. So proxy server is a system or a router that provides a gateway between users and the internet. So network modeling tools, as you translate the OSI logical model into a physical model of the network system, you can use software tools. Uh, these tools basically model-based testing tools which actually generates test inputs or uh, test cases. So we have a network classes issues and network license issues is based on client server architecture where licenses are placed on a centralized system in the subnet. And we have also software licensing restriction. So a wireless local area network or WLAN. Wireless network standard is 80.2, 802.11, or uh, and we have 802.11 AC. It is 600 162.5 Mbps megabytes per second. This is 3 times faster than the typical 450 Mbps speed attribute to uh, 8 802.11n. So wireless network standards, it's 802.11G. Uh, it is a Wi-Fi standard developed by the IEEE for transmitting data over the wireless network. So we have also 802.11n. It's capable of operating in both 2.4 gigahertz and 5 gigahertz. So we have also multiple input and or multiple output or MIMO. It's a radio communication technology of RF technology that is being mentioned and used in many new technology these days. So wireless network topology, basic service set, or BSS infrastructure mode. So it is a term used to describe the collection of stations which may communicate together within an 802.11 network. So access point, it is a device that creates a wireless in a local area network, usually in office or a large building. So extended service set, or ESS, it is an extended service set. It is consisting of a set of BSS and must have a common service set, identifier, or SSID. So we have also the independent service set, and it is a peer-to-peer mode. So wireless trend, uh, Wi- Wi-Fi Alliance, it's the non-profit organization that owns the Wi-Fi trademark. So manufacturers may use the trademark to uh, brand products certified for Wi-Fi interoperability. So we have also uh, Wi-Fi and Bluetooth. On addition to 802.11 protocols for LANs, IEE is working from 802.11 16 standards. So we have a metropolitan area network uh, also. So this is my references, and thank you po.
Mhm. Okay, thank you very much. So as you can see here, no, based on the given discussions of our presenter, no, it's just focus on a while ago, no, I shared to you about the software, no, architecture. So this time, our presenter discussed about the system architecture. So maybe somebody are asking, is there any differences between system architecture and software architecture at the same time? So uh, of course, when we say system architecture, it is a conceptual model that describes the structure and behavior of a multiple components and subsystems like multiple software applications, network devices, hardware, and even other machinery of the system. It is the architectural or architecture description language which helps to describe the entire system architecture. So it is so much broader topic. System architecture can be broadly categorized into centralized and decentralized architectural organizations. On the other hand, no, the software architecture, it refers to the process of creating high-level structure of a software system. No? So it is about the complete structure or architecture of the overall system, means it converts software characteristics like scalability, security, reusability, extensibility, modularity, maintainability, and others into structured solutions, no, to meet the business requirement. Multiple high-level architecture patterns and principles are followed during defining architecture of a system. It mainly focuses more on externally visible components of the system and their interaction with each other. So, let's say, for example, a system architecture is a conceptual model that describe the structure and behavior of multiple components and subsystems like multiple software, application, network devices, hardware, and even machinery of a system. The software architecture refers to the process now of creating high-level structure of a software system. So the system architecture focus on the entire system. The software architecture focus on the components. Take note of it, ha? The system focus or in the system architecture, various type of system architecture are hardware, architecture, enterprise architecture, collaborative system architecture. In software, patterns include serverless architecture, event-driven architecture, and microservice architecture. Okay. In system, it helps to define low-level infrastructure of a software. In software, it helps to define high-level infrastructure of a software. Sa system, low-level infrastructure. Sa software, high-level infrastructure of a software. In system, building overall is system architecture. But in software, building individually is a software architecture. Okay? For system, includes element of both hardware, and it is used to enable design of such a composite system. For the software architecture, it considers different factors such as business strategy, human dynamics, quality attributes, design, and IT environment. System architecture defines structure, behavior, and view of a system. Software architecture defines the solution to meet technical and business requirements. Okay? I just want to to give you a different perspective of the system and software architecture. Okay. System architecture is in one line overall view of all components and their relationship is called system architecture. But in software architecture is align individual components and its relationship with other. No? So an example of a system architecture, let's say, for an order entering system contains web front end, business layer service, web back end, and database. But for software architecture, it is one component ordering system is web front end. Take note, web front end, which consists of responsive user interface, view controller, web services, and many more. So this is the way on how we'll be able to differentiate the system and software architecture. Again, system architecture is a conceptual model that describes the structure and behavior of a multiple and subsystems like multiple software applications, network services, network devices, hardware, and even other machinery of the system. Okay? The software architecture refers to the process of creating high-level structure of a software system. It is about the complete structure, architecture of all overall systems. Means it converts software characteristic like scalability, security, reusability, extensibility, modularity, and maintainability, and others into a structured solution to meet the business requirements. Okay, so, and I think that's it.